Let me begin with a thought that shocks people every time I say it. By the laws of nature, by the limitations of technology, and by every reasonable prediction of science in the mid-20th century, landing humans on the moon should have been impossible. And yet, we did it. This is the paradox of human civilization. Again and again, we redefine what impossible means. When you look at the moon, hanging peacefully in the night sky, it appears eternal, unreachable, a silent witness to billions of years of cosmic history. For most of human existence, it was nothing more than a glowing mystery. But then came a moment, an extraordinary moment, when a species that had only recently mastered electricity decided to touch the heavens. Scientifically speaking, the moon landing is not just an engineering triumph. It is a psychological breakthrough. We pushed against limits of gravity, limits of biology, limits of physics, and discovered that the barrier labeled impossible is often nothing more than a boundary of imagination. In 1969, the human race looked up and said, why not? And that question has been the engine of scientific progress ever since. People often ask me, if it was so difficult, how did we do it? And I answer with something simple. Because every generation stands on the shoulders of the previous one. We built rockets on the dreams of astronomers, trajectories on the equation of Newton, and communication systems on the theories of Einstein. A moon landing is not the triumph of a single nation. It is the cumulative achievement of 200,000 years of human curiosity. But the lesson isn't about the moon. The lesson is this: every time humanity touches the impossible, the future expands. The moon was merely the first step. Mars, exoplanets, and even interstellar travel, these are not fantasy. They are future engineering problems, waiting for solutions. And one day we may look back and say that standing on the moon was just the moment humanity learned to crawl in the cosmic ocean. So when someone tells you something can't be done, remember this: the word impossible has a very short lifespan in the hands of human ingenuity. If we reach the moon with computers weaker than a modern calculator, imagine what we can reach today. When people hear the word impossible, they often imagine a brick wall, a dead end, a signal that they've reached the limit of what can be achieved. But if you watch history unfold long enough, you start to notice a pattern. What one generation calls impossible often becomes the standard operating procedure of the next. It's almost amusing how frequently the world misjudges the future. The telephone was once dismissed as a toy, the airplane as a dangerous fantasy, and the computer as something no normal household would ever need. Yet here we are, living in a world where a device in your pocket contains more computational power than the machines that guided astronauts to the moon. And that is the strange thing about the impossible. It bends, it shifts, it yields to persistence, ingenuity, and a little bit of stubborn optimism from the people who refuse to accept the status quo. When you study the first keynote, that the impossible exists only until physics catches up, you begin to see that humanity's progress is not a straight line, but a series of leaps that often happen when someone takes a hard look at a problem and says there must be a better way. The truth is, the laws of physics never change. Gravity pulls today exactly as it did 1 million years ago. Light travels at the same speed. Electrons behave in the same predictable patterns, and thermodynamics doesn't cut anyone a special deal. What does change is our understanding of those laws. The moment someone understands a principle at a deeper level, innovation follows like a shadow, and gradually the barrier that once looked solid becomes permeable. Look at aviation. People had been dreaming about flying for thousands of years. The myths, the drawings, the contraptions, they all pointed to a desire that seemed embedded in human nature. But physics didn't move. Our understanding did. Bernoulli's principle, lift, propulsion, these ideas didn't develop overnight. They built slowly, painfully, through trial and error, through failures that embarrassed entire workshops. But eventually, the gap between desire and physics began to close. Humanity didn't suddenly gain new rights from nature. We simply learned to operate within the rules more intelligently. And once we did, the impossible dissolved. The moon landing fits into that same pattern, a result not of breaking physical laws, but respecting them, studying them, and designing solutions that navigated every constraint carefully. For thousands of years, the moon was unreachable. The distance was too great, the vacuum too unforgiving, the temperature swings too extreme, and the physics too complex for early civilizations to even imagine bridging that gap. But as human knowledge deepened Newton's laws, Maxwell's equations, breakthroughs in material science, the impossible began to shrink. Slowly, the moon transformed from a poetic symbol into a target for engineering. The laws of physics didn't change, we just became better students. And that's a lesson worth remembering today. If you want to understand how the impossible softens over time, look at how innovation compounds. It's not so different from money. A small breakthrough left untouched doesn't do much, but when one breakthrough builds on another, and those layers stack for decades or centuries, the result becomes something that looks miraculous to anyone who didn't witness the long, slow march that led to it. The compounding of knowledge is one of the most powerful forces available to civilization. Every time a researcher publishes a paper, every time a student asks a better question, Every time an engineer tightens a bolt on a new kind of machine, they are adding a penny to the global savings account of innovation. And over time, the interest rate on human ingenuity has been nothing short of extraordinary. But even with physics as the gatekeeper of possibility, the second keynote reminds us that understanding the rules is only half the story. When a frontier is reached, whether it's on Earth or in space, it demands a mindset that is different from everyday thinking. The obstacles are bigger, the risks are higher, the comfort zone is smaller, and many people, when they encounter friction, choose retreat instead of persistence. But those who redefine what's possible have a different relationship with adversity. They don't avoid it, they sit with it, examine it, turn it over in their hands like a puzzle piece that hasn't found its place yet. You can see that mindset in the early space pioneers. They were working with slide rules, chalkboards, and machines that would look like museum pieces today. The odds of success were thin, and the consequences of failure were severe. But the people involved didn't fixate on the danger. They fixated on the goal. They had a way of shrinking problems down to size, refusing to be intimidated by their scope. It wasn't recklessness, but a disciplined form of optimism, the belief that even the biggest wall is made of smaller bricks that can be analyzed, replaced, or rearranged. There's something valuable in that perspective. Whenever a society sets out to do something unprecedented, the first step is almost always psychological. Someone has to give themselves permission to imagine a world that doesn't exist yet. And that kind of imagination isn't whimsical, it's strategic. It's what allows people to see a path where others see fog. It's what separates the thinkers who wait for certainty from the ones who proceed with caution but refuse to stand still. And once that mindset takes hold, it becomes contagious. Entire teams begin to align behind a shared belief that a problem can be solved, even when that belief is held together by nothing more than equations on paper and an intuition that the pieces will eventually fit. When a frontier is new, the mindset must be flexible. It must accommodate failure, because failure will come early and often. But failure in this context isn't a verdict. It's data. It's information about what not to do next time. And the people who advance civilization forward tend to treat failure like a tax on progress, unpleasant but necessary, paid in service of a larger return. That's why confidence matters, not blind confidence, but the calm, reasoned confidence that grows from preparation and repeated effort. It's the kind of confidence that says we may not have the answer yet, but we will. Consider the early lunar mission. There were explosions, miscalculations, communication failures, and equipment that barely worked, even under ideal conditions. But the people involved approached each setback with the mindset of investors watching a portfolio swing. They didn't panic. They assessed, revised, recalibrated. They made decisions not based on emotion, but on probability, on the long-term view, on the belief that if you keep your losses controlled and your gains multiplying, you eventually reach your target. And that's the interesting thing about this mindset. It translates into nearly every field. Whether you're trying to build a business, launch a spacecraft, or solve a scientific problem, the mental framework is the same. You break complexity into pieces. You build models. You test assumptions. You focus on what you can control. And little by little, the impossible turns into a risky possibility, then a viable option, and eventually an achievement that feels inevitable in hindsight. The moon landing demanded more than intelligence. It demanded resilience, discipline, and an unusual tolerance for uncertainty. It demanded people who were comfortable working without a safety net, people who respected the unknown but refused to be ruled by it. And when you gather enough minds like that in one room, something remarkable happens. Ambition stops being a dream and starts becoming strategy. That is why understanding physics isn't enough. You can know every formula, every law, every constraint, and still fail to reach the frontier if your mindset isn't prepared for the weight of the challenge. The pioneers of every major advancement share a common trait. They are able to imagine the world not as it is, but as it could be. And then they commit themselves to closing the gap between the two. They embrace uncertainty not because they enjoy risk, but because progress leaves no other choice. They take setbacks in stride because they know that forward motion, even slow and uneven, is better than conceding to stagnation. And they understand that the future belongs not to those who wait for perfect conditions, but to those who build the conditions themselves. When you bring these two keynotes together, the evolving understanding of physics and the mindset required to explore new frontiers, you get a picture of progress that is both practical and inspiring. You realize that the impossible is not a fixed truth, but a moving target, influenced by knowledge, creativity, and the willingness to act. And once you internalize that, the world looks different. Problems become challenges. Challenges become opportunities. And opportunities become the stepping stones that carry civilization forward. When people talk about great achievements, they often focus on the individuals who stood in the spotlight, the astronauts, the engineers, the leaders who made the announcements. But when you look closely at the third keynote, the idea that the moon landing proved civilization can collaborate at scale, you begin to see that the real power came not from a single genius, but from an enormous, coordinated effort across countless disciplines. You can think of it the way you think about a large business. A company isn't built by one person, even if one person's name ends up on the building. It's built by the quiet contributions of thousands of people whose names never made the headlines, but whose work forms the backbone of everything that becomes possible. The moon landing was the same. No single person understood the entire system. It was too complicated, too broad, too multilayered for any one mind to hold. Yet thousands of people, each specializing in their own piece of the puzzle, aligned behind a shared mission. There is something deeply instructive about that. Most people underrate the value of collaboration because it's invisible. If a rocket launches successfully, nobody thinks about the machinist who tightened a bolt, or the mathematician who computed a trajectory adjustment, or the materials scientist who spent months perfecting a component so small you could miss it in the palm of your hand. But without each of those people, the mission would have failed. That's the nature of large endeavors. They succeed because thousands of small, unglamorous decisions were made correctly. And when you zoom out, you begin to appreciate that the moon landing wasn't simply a technological triumph. It was a demonstration of what humanity becomes capable of when egos are set aside and the goal is placed above individual recognition. Now, that kind of collaboration doesn't happen naturally. It requires structure, trust, and the kind of leadership that can keep people aligned when the stakes are high and the margin for error is razor thin. When thousands of people are working on one project, communication becomes as critical as engineering. A misunderstanding in one department can create a problem that won't show up until months later, when fixing it becomes expensive or dangerous. That's why the people who orchestrated the lunar missions spent enormous effort creating systems to ensure that information flowed efficiently, transparently, and accurately. They understood that complexity demands order, and order demands communication. You can draw a straight line from that mindset to the practices used today in large companies, advanced research labs, and international scientific efforts. But there's more to it than coordination. Collaboration at that scale also requires humility. People must accept that they are part of something bigger, that their contribution matters, but is not the whole. In a world that often celebrates individual achievement, humility is sometimes seen as a weakness. But when you observe large-scale collaboration, you notice that humility is one of its strongest pillars. The person designing a fuel valve doesn't need to understand orbital mechanics. They just need to trust that someone else does. The person programming the communication system doesn't need to understand metallurgy. They just need to trust that the materials team built something reliable. Every person focuses intensely on their part, trusting that others will do the same. This kind of trust isn't automatic. It's earned through competence, clarity, and a shared belief that everyone is working toward the same result. And when that trust becomes widespread, something powerful happens. The whole system starts to behave like a single organism. Information flows smoothly, decisions get made faster, and the collective intelligence becomes far greater than the sum of individual minds. In investing, you often hear about synergy, where two companies combine, and the result is more valuable than the two were separately. Large-scale scientific collaboration works the same way. The combined output is far greater than you could get from isolated efforts. When you reflect on all of this, you realize that the moon landing was one of the first times humanity proved it could execute a project so vast, so complex, and so interdependent that it required a civilization-level effort. It was a sign that when people work together with discipline, precision, and a shared mission, their capacity expands dramatically. That has tremendous implications for the future. Problems like climate change, energy scarcity, disease prevention, and space exploration are all larger than any individual country or discipline. They require the same kind of broad, multi-layered cooperation that put people on the moon. And the moon landing showed that humanity is capable of doing exactly that. It set a precedent that collaboration, when done correctly, multiplies our abilities far beyond anything we can achieve alone. Now, when you transition to the fourth keynote, the idea that the first step on the moon was the first step toward a multi-planet future, you begin to see how the success of one mission reshaped the boundaries of our ambitions. Before that footprint settled into the lunar dust, the moon was the limit. It was the ultimate symbol of distance and difficulty. But the moment a human being stood there, the mental map of the possible changed. It's a bit like watching someone break a 4-minute mile. Before the first runner did it, everyone believed it was impossible. After he did it, several others achieved the same feat within months. The barrier hadn't changed, the belief had. The moon landing had that same psychological effect on civilization. Once the impossible became a memory, the next frontier started to look less like a fantasy and more like the next logical challenge. That psychological shift is important. People often imagine progress as a steady march, but most of the time it moves in leaps. Someone proves something can be done, and suddenly the world recalculates what the future could look like. Before the moon, human exploration was tied to Earth. Afterwards, it became tied to possibility. Mars, asteroids, Planetary bases, these ideas didn't originate after 1969, but they gained momentum once the moon was no longer theoretical. And just like the moon landing itself, these next steps rely not on one grand breakthrough, but on incremental advances that stack gradually until a tipping point is reached. Think about how much technology has changed since 1969. Materials have improved dramatically. Computing power has grown by factors that would have seemed absurd to the early space engineers. Communication speed, imaging systems, robotics, energy storage, all of these areas have advanced enough to make future missions more feasible. The seeds planted by the Apollo era have been sprouting for decades, and now you're seeing the effects. Commercial space companies are reducing the cost of launches. Autonomous systems are making remote exploration more practical. New propulsion methods are being developed that could cut travel times dramatically. And all these advancements are pointing toward a future where humanity can operate not just around Earth, but across the solar system. But a multi-planet future isn't just about technology. It's also about mindset and economics. Humans are creatures of habit, and we adapt our expectations based on what we've already accomplished. Once a civilization touches another celestial body, the desire to go further becomes less of a dream and more of a plan. That's how ambition works. Once you see a new horizon, you start to wonder what lies beyond it. And once enough people share that curiosity, industries form, investments grow, and innovation accelerates. Consider the long-term implications. A species that occupies more than one planet becomes more resilient. It gains access to new resources, new environments, and new opportunities to grow. It reduces its vulnerability to threats confined to a single world. It opens doors to industries we can barely imagine today: off-world manufacturing, space-based energy, extraction of materials that don't exist on Earth. These ideas might seem distant now, but so did the moon landing once. And just as the moon landing became the catalyst for whole new sectors of technology, next steps into space will inevitably create opportunities that spill into everyday life. There is also a financial principle at play here. The earlier you invest in a frontier, the greater the long-term rewards tend to be. Early investments rarely look comfortable. They look risky, uncertain, unpredictable, but they also carry the greatest potential. When you study how industries mature, you see the same pattern again and again. Railroads, electricity, aviation, the internet each began as a high-risk venture with unclear returns, pursued by people who were driven more by vision than certainty. But once the infrastructure was built, the world shifted and the returns grew enormously. Space is likely to follow that same curve. Early efforts are expensive and uneven, but the direction is clear. When you combine these ideas, the collaborative power that made the moon landing possible and the psychological shift it created in humanity's ambition, you begin to understand that the first footprint on the moon was not just a scientific milestone, but a preview of civilization's long-term trajectory. It showed that when people unite behind a shared mission, they can overcome staggering odds. It showed that technological limits are flexible and that imagination can bend the arc of progress. And it opened a door to the rest of the solar system, a door that will continue to widen as knowledge compounds and ambition grows. When you look at the fifth keynote, the idea that modern technology makes the next impossible within reach, you begin to understand something that becomes clearer the older you get. Progress doesn't move in a straight line, it moves in waves. Most people underestimate how quickly things can change because they assume tomorrow will look like today, just with slightly better tools. But that's not how breakthroughs work. When a new technology arrives, it often changes the slope of the curve, not just the height. It accelerates the pace at which new possibilities become realistic, and when you zoom out over decades, the compounding effect of technological improvement becomes astonishing. If you compare the tools available today with those available when the moon landing happened, it's almost humorous how far we've come. Back then, computers filled entire rooms, ran on punch cards, and had less computing power than the devices we casually carry in our pockets. Today, you have artificial intelligence capable of processing data at speeds no human team could match. You have quantum computing on the horizon, promising leaps that make previous advances look incremental. You have reusable rockets lowering costs, robotics performing delicate tasks in environments where humans can't safely operate, and materials stronger, lighter, and smarter than anything the engineers of the 1960s could have imagined. All of these developments make the once impossible not only possible, but increasingly practical. But it's important to understand that technology by itself is not enough. What matters most is how it's used, how it's coordinated, and how it's integrated into a larger strategy. In investing, you often see businesses with brilliant technology fail because they don't know how to deploy it effectively. They have the tools, but not the plan. The same is true for civilization. Technology is an enabler, not a destination. It gives us leverage, but leverage only matters when applied in the right direction. When modern tools are combined with disciplined thinking, long-term planning, and a clear sense of purpose, they become transformative. Without that combination, they are little more than curiosities. When you look at today's landscape, what stands out most is how many fields are converging. In the past, breakthroughs often happened in isolation. A discovery in physics affected physicists. A new material affected manufacturing. A new communication tool helped businesses. But now, technologies don't just advance, they amplify one another. Improvements in computing accelerate progress in medicine. Advances in robotics push forward developments in energy. Better energy systems empower advances in manufacturing and space travel. Everything is connected in a way that creates a multiplier effect. And when technologies compound on top of one another, the rate at which the impossible becomes possible increases dramatically. Consider reusable rockets. For decades, the biggest barrier to space exploration wasn't distance or danger, it was cost. Launching anything into space was so expensive that even small missions required budgets that could only be justified by governments. But once rockets could be reused instead of thrown away after a single flight, the economics shifted. Suddenly, companies could enter the arena. Innovation accelerated because incentives expanded, and that's how breakthroughs usually happen. Not through one genius idea, but through changes that open doors for thousands of others to experiment, build, and improve. The same pattern applies to artificial intelligence. Decades ago, it was a concept limited to academic papers and speculative fiction. Today, it's a practical tool that can analyze risks, detect patterns, optimize systems, and solve problems that would take teams of people months or years. When you apply AI to scientific research, engineering design, financial modeling, or space exploration, you reduce the time between idea and execution. And when that time shrinks, progress accelerates. Progress is not just about speed, it's also about accuracy. One of the biggest challenges in large-scale projects is uncertainty. The more unknowns you face, the more expensive mistakes become. Modern tools reduce uncertainty. They allow simulations that predict outcomes before a single piece of hardware is built. They allow materials to be tested digitally before they are manufactured physically. They allow trajectories, temperatures, pressures, and risk scenarios to be modeled with astonishing precision. And when you reduce uncertainty, you reduce cost. When you reduce cost, you increase experimentation. When you increase experimentation, you increase breakthroughs. That is how modern technology takes something that once seemed impossible and brings it within reach. Another factor worth noting is accessibility. Technology that was once reserved for governments and research institutions is now available to universities, startups, and in some cases, individuals. The barrier to entry has fallen dramatically. And when more people can participate in solving big problems, the probability of solving those problems increases, competition grows, creativity expands, and unexpected solutions emerge. Innovation doesn't belong to a closed group anymore. It belongs to a global community with diverse backgrounds, perspectives, and incentives, of course. None of this guarantees success. Technology gives us the tools, but it doesn't guarantee wise decisions. That depends on leadership, judgment, and long-term thinking. It depends on people who are willing to look beyond immediate benefit and consider what the next decade or the next generation will need. Technology expands what's possible, but it doesn't replace the need for discipline. In fact, the more powerful the tools become, the more important discipline becomes. Just as leverage in investing can magnify gains or losses, advanced technology can amplify outcomes, positive or negative, depending on how it's used. That's why understanding the direction of progress matters. If technology continues to improve and history suggests it will, then the boundaries of the possible will continue to expand. The things that look difficult today may look routine tomorrow. The challenges that seem insurmountable may one day be seen as stepping stones. Human progress thrives when knowledge accumulates, when tools improve, and when people are willing to pursue difficult goals with patience and persistence. And if history teaches us anything, it's that the combination of curiosity, ingenuity, and disciplined effort has a remarkable track record of turning yesterday's impossibilities into tomorrow's achievements.